Hello, and welcome to the second question on hypothesis testing using the z-test. So, in this question, we are told a manufacturer claims that the mean lifespan of a particular brand of light bulbs is at least 1,000 hours, which is 1,000 hours. So, a sample of 100, okay, a sample of 100 light bulbs is tested, and it is found that the mean lifespan is at 980 hours with a standard deviation of 120 hours. So now here the question is saying conduct a Z test to determine if there is evidence to support the manufacturer's claim at a significance level of 0.05. Okay, so the first thing that you do, obviously, when you're solving this question, first you're going to state the hypothesis, that is the null hypothesis, as well as the alternative hypothesis. So for the null hypothesis test, we are told in the question that how many bulbs were gotten there, at least we are saying the claim that the lifespan of a particular bulb is at least 1,000 hours. So that is a claim. 1,000 hours. So at least means greater than or equal to 1,000. Okay. Then for the alternative hypothesis that we have, we want to see if this claim it is true, or maybe it can be less than those hours that they said. Okay. That is the alternative hypothesis that we are going to have. So now what are we looking at? The third step that we are going to do, obviously, which is the second step, we are going to state the significance level that we have. Okay, so we choose. So we are going to choose. We'll choose the significance level, and here we've been told again. So alpha is simply equal to 0.05 because it was stated in the question. Okay, the researcher stated that the significance level is at 0.05. Okay, so we've chosen that. So now we are going to calculate using the z-test formula. Okay, that is the third step that you're going to do. We're going to calculate. So we'll calculate the test statistic. Okay, so it depends obviously what your lecturer wants. This order maybe doesn't matter, but that is simply the basic on how you calculate whenever you're given a question. So here we're going to calculate the test statistic. So in this case, we already know this is the mean that you have, isn't it? So you've already identified. So that is the sample mean. So for the sample mean, in this case, we are given it is what? So for the sample mean, of course, we are told it's 980. That is the sample mean. Okay, the sample mean is 180. Then the mean population of what you're told the hours for mu, it is simply what? 1,000. That is what you have. Okay, then the standard deviation that it has a standard deviation of 120. And what is the sample size? So for n here, which will be for the sample size, it is simply 1,000. That is what you're going to get. So you have the sample mean that you have. Okay, then you have the population mean, the population standard deviation, as well as the sample size. So now let's use this formula. Of course, you know the formula for the z-test. Okay, so in this case we're going to say z is equal to that minus mu, okay, over. So you have the standard deviation here is being divided by the root of n. So in this case, what we're going to have on the mean, the sample mean, we already know the sample mean here, it is 980. We are going to subtract from 1,000. Okay, everything over, we are going to have the standard deviation of 120. This we are dividing by the root of 100. Okay, That is what you're going to have. And what are you going to have here? You're going to have negative 120 divided by, oh sorry, you're going to have 20, not 120. So that minus that will give you 20. So you're going to have negative 20, everything divided by, so you're going to have 120. Then what is the square root of 100? Of course, you know the square root of 100 will simply give you what? Simply give you 10. Okay, you simply give you 10. And from there, of course, as a mathematician, when you simplify that one further, what are you going to have? If you simplify this one, you are going to have negative 20, okay, divided by what? Divided by 12. And this will simply give you the value of negative 1.667. That is what you're going to have, okay? So that is the value that you're going to have, the test statistic that you're going to compare against the null hypothesis. Okay. Then question 4, I mean the step number 4, we are going to determine the critical value. Okay. We're going to determine the critical value. So now if you look at this test, because it specifies, okay, so it is a one-tailed test. Okay. So this is a one-tailed test, and we know the significance value that you've been given it at 0.05. So I've done a video on how you can find the critical value that can help you, but in this case I simply explain. So for a one-tailed test, simply get the same value, but for the critical value, of course, for a two-tailed test, because it is 2, usually multiply by 2, but in this case we've already been given 0.05 for the significance value that we have. So now the critical, okay, the critical z value in this case, we are simply going to have the value that is less than the same value, which is negative 1.645. So I'm sure you can still recall on the degree of freedom. Don't know if you still remember that, how you can find for the critical values and all that, but that is what you have. You're going to have negative 1.645. Then after that is the value that you're going to have. Last thing that you're going to do, you're going to make a decision. So now what would be your decision? Okay, so the decision that you're going to make, you're going to say the calculated, okay, the calculated z value, the one that you calculated when you're doing the tests, when you're doing the test statistic, the value that we found, it is negative 1.667. Okay, that is what we found. Okay, which is less than negative 1.645. Okay, for the critical value. Okay, so now you're comparing. So negative 1.667 is less than negative 1.645. So if this is what you found, you're going to say therefore, okay, therefore we reject the null hypothesis. So if we reject the null hypothesis, what will be our conclusion if we reject it? We reject the null hypothesis test. So our conclusion, okay, our conclusion, we are going to say there is significant evidence there is significant evidence to suggest there is significant evidence to suggest that the mean lifespan the mean lifespan of a light bulb is less than the 1000 hours that we are told. Okay, so there is enough evidence, there is significant evidence to suggest that the mean lifespan of a light bulb is less than 1000, because we saw when you compare those two values, the z value that we calculated and the z value for a one tailed test, which is negative 1.4645, which is less than negative 1.667, okay, which is greater than, I mean, negative 1.667. So now you see that when you compare these two values, one is greater than the other. So we are going to conclude by saying there is significant evidence to suggest that the mean lifespan of a light bulb is less than what the manufacturer claimed, which was 1000 hours, 1000 hours. So it is less than that. Okay, let's look at the next example and see if it is still going to make some sense.